Hello friends, today is the second part in organic chemistry, basic principles and techniques. I hope you have followed the previous session wherein we have studied about purification methods, and the first method was sublimation. Today we shall study some more purification methods, and the second method of purification is crystallization. It is crystallization. This method of purification, crystallization, is usually followed for solid organic compounds. It is used to purify solid organic compounds. If you have an organic compound which is impure, if you have a solid organic compound which is impure, then it can be purified by crystallization. On what basis? I mean, what principle is followed in crystallization? Crystallization is the most commonest method used for purifying solid impure organic compounds, and it is based on the principle that the given organic compound and the impurities associated with the organic compound, they should be differing in their solubility in a given solvent. I mean, this method is based on the differences in the solubility of a given organic compound and the impurities in a particular solvent. This also means if you have an organic compound which is impure and the impurities are present in it, then out of these two, only one should be soluble in a given solvent and the other should not be. I mean to say, when you have organic compound along with impurities, only the organic compound should be soluble in a solvent, whereas the impurities should be insoluble in one particular solvent. Now say, if I tell you, you have got impure sugar is mixed with some impurities, say sand particles, etc. What solvent will you choose for purifying sugar? You will choose obviously water, because water dissolves sugar but it does not dissolve the sand particles. Hence, we can say that this method, crystallization, is based on the principle that the impurities and the organic compound should differ in their solubilities in a given solvent. Now, how is this done? The main step involved in purification of solid organic compound through crystallization is, first the given organic compound should be powdered, then it should be dissolved in a solvent and heated. What is done? The given impure organic compound is powdered and dissolved in a solvent. After dissolving in the solvent, it is subjected to heating. The solution is now heated. The impure organic compound is powdered and mixed in a solvent, stirred. After solubilizing, after dissolving, the solution is heated. Till when? Till the solution becomes saturated. The solution is heated till when? Till it becomes saturated. You may ask, sir, what saturation means? Till the solution becomes somewhat thicker or viscous. When the concentration of the solute begins to increase in the solution, we call that solution as saturated solution. Now, when the solution has become saturated, when it is still hot, when the solution is still hot, it is filtered. It is filtered using a filter paper. I can demonstrate you how this is done. Say you have seen yesterday how glass funnel is inverted in sublimation. The same glass funnel is taken and inside which a filter paper is fitted, in the form of cone. Now from here you add solution containing your impure organic compound, or in other words organic compound along with impurities. It is added. Then this glass funnel is kept in a beaker. This glass funnel is kept in a beaker. For what? For collecting the clear solution or filtrate. After this apparatus is set, when the solution is added, now drop wise the solution begins to drip into the beaker meant for collecting the filtrate. What is filtrate? Filtrate is the solution obtained after filtration. Okay. Now, once you have collected the filtrate, what remains inside the filter paper in the sieve? It is nothing but residue or impurities. So these impurities are thrown away, and this clear filtrate is still in liquid form only. It is not solid. You need solid organic compound in the purest form. For this to happen, this filtrate is removed. After all the solution has been filtered, this filtrate is removed and the filtrate is again somewhat heated and then cooled. When you begin to notice that inside the solution crystals are beginning to appear, then let the solution cool and leave it undisturbed. Leave it undisturbed for some time. After some time, when the crystals have been formed, then decant the solution if possible, or else you filter the solution. Pure crystals will be obtained in the purest form. These crystals are dried and used. This is the method of crystallization, a very easiest and simplest method to follow in purification of solid organic compounds. I will again revise how this is done. So the principle of crystallization is, it depends on the difference in the solubilities of the organic compound and the impurities in a particular solvent, and it is the most commonest method used to purify solid impure organic compounds. What is the procedure followed? The given impure organic compound is powdered, mixed with a solvent such that the organic compound should dissolve in the solvent, but the impurities should be insoluble. Then this solution is subjected to heating. After heating, the hot solution is filtered through a filter paper and filtrate is collected. The impurities remain behind in the filter paper. We call them as residue. It is thrown away. The clear filtrate obtained is again heated and then cooled. Upon cooling, crystals of the pure organic compound will begin to appear. Once when all the crystals have formed in the beaker, then the solution is decanted or filtered depending on the conditions, and the pure crystals obtained are filtered, dried and used. That is crystallization. Then we have another method of purification, and it is the third method. This method is distillation. You have studied distillation even in your school days, so I hope this won't become difficult for you to understand. Distillation is done usually for liquid organic compounds. It is done when you have liquid organic compounds which are impure. Sometimes if any liquid organic compound is mixed with impurities, then they can be separated by distillation. If two organic liquids, even though they are pure, they are not impure, if two pure organic liquids by accidentally they got mixed, then also they can be separated by distillation. So distillation is a purification process and it is also a separation process. You can separate two organic liquid mixture into separate organic liquids, and you can also purify an impure organic liquid. Depending on the nature of the liquids mixed, we have different types of distillation. Like we have simple distillation, that is first type we have simple distillation, then we have fractional distillation, then we have distillation under reduced pressure, distillation under reduced pressure, and finally we have steam distillation. So in this year, in your first year syllabus, you will be studying these 4 distillations. Let us begin with the first one, simple distillation. Let us begin with simple distillation. This is the first type under third heading, distillation. What is simple distillation? Simple distillation is a purification technique used to purify those organic liquids which have very large difference in their boiling points. Boiling point in Kannada is Kudiyuva Bindu. If you have 2 liquids, they got mixed, and if the difference in their boiling points is very large, the difference in their boiling points is very large, only then simple distillation can be used. If you have 2 liquids whose boiling point differ only by 10 degrees or 15 degrees, then simple distillation cannot be used. We have other distillation methods. This technique is used only for those organic liquids whose boiling point difference is large. Sir, how do I know? For example, if you have chloroform, it is one of the organic liquids, chloroform, and then if you have aniline, then you have aniline. Chloroform and aniline means benzene ring with NH2. If these two are mixed with each other, aniline's boiling point is 184 degrees Celsius and chloroform, if I am not wrong, it is 61 degrees Celsius. Okay. Now we have 2 liquids whose boiling point difference is very large. You subtract 61 from 184, it is very large difference. So only those liquids whose boiling point difference is very large, they can be separated by simple distillation. Okay. Now how this is done? You first see the setup or a apparatus, how it is done. Then we shall see the technique, 61 degrees Celsius and 184 degrees Celsius. So in the first step, you take a round bottomed flask, into which organic liquid mixture is present. Okay, so you have mixture of organic liquids like chloroform and aniline. Then depending on their nature, you either use a sand bath or water bath. Then place it on a wire gauze, that has been kept over a stand, underneath a burner is kept, for lighting. Now do not heat this solution. What do you do? You take the mixture of impure organic liquid into round bottom flask. This round bottom flask neck has got a side tube. It has got a side tube. Okay. Then the round bottom flask is fitted with a cork for closing. It is fitted with a cork for closing, having a small gap inside for thermometer. Okay, this is your thermometer. Then Once when this setup is done, so you have a thermometer. This is side tube. Okay, this side tube is connected to a water condenser. I'll tell you what water condenser is. You simply now go through the diagram. This is a water condenser. Then this water condenser now opens into a receiver. It now opens into a receiver. Okay. Now when this setup is done, the water condenser has got two openings. It has got two openings. The water condenser is fitted on a stand for support. Okay. It is fitted on a stand for support. Similarly, you need a stand for support in supporting the round bottom flask also. Okay. Whenever these questions appear in exam and diagrams are compulsory, you need to label them also. Labeling is also compulsory. So beginning from here, this is stand. Okay. Then this is round bottomed flask. Okay. Then this is mixture of organic liquids, or you can simply say impure liquids, impure liquid. Then this is sand bath or water bath if required, otherwise no. Here is burner and or simply Bunsen burner. Then we have thermometer. I'll tell you what it is required for, what thermometer is required for. Then we have water condenser. There are two openings, I said. The latter opening is called inlet and this is outlet. Then we have receiver for collecting purified liquid, Okay. Once when this experimental setup is done, now let us see how purification is done. So the impure organic liquid is taken into a round bottomed flask. What is a round bottomed flask? You might have seen some glass apparatus even in your home, like the glass that you use for drinking, isn't it? So if you have got a round bowl like structure, globular structure with a neck, it is round bottomed flask. Inside that round bottom flask, you pour the impure organic liquid, and this round bottomed flask is fitted with a thermometer. What for? To notice the temperature, to notice the boiling point of the two liquids present inside the round bottom flask. Then this round bottomed flask has got a side tube. It has got a side tube which connects this side tube to a water condenser. you see that the water condenser is a long cylindrical structure inside which the vapors can pass, but on the outer sides it is empty for circulation of water. I'll come back there later. Now this round bottom flask is fitted with a stand and kept on a sand bath or water bath. Notice that, and remember, if the liquid to be heated has got higher boiling point, then you need not use a sand bath or water bath. Direct heating is enough. If one of the liquids has got very low boiling point, like in this case chloroform has got 61, then indirect heating is required. For that reason, depending on the nature of liquid, you can either use a sand bath or water bath. If the boiling points are very high, you need not use them. Then this side tube connects to a water condenser. Water condenser's other end opens into a receiver. You can keep a beaker, you can keep any conical flask fitted with a cork, etc. Now, the water condenser has got two openings, I said, one is inlet and outlet. You may say, sir, why can't I write here inlet? No. This opening here, it is connected to water tap, and tap is opened so that water continuously flows inside. This entire part should be always filled with water, should always be filled with running water, so that the temperature inside the water condenser remains cool, it remains low. Why do we need this low temperature? I will tell you after some time. And from the other end, water that has been sent inside, it becomes warmer due to the incoming vapors. That water is let outside. After this setup is done, now you take the impure organic liquid inside the round bottom flask and begin to heat. When you heat this, you have two liquids, one which boils at 61 degrees Celsius and the other which boils at 184 degrees Celsius. So out of these two, which liquid will vaporize first? It is obviously chloroform. So out of the two liquids, only chloroform vapors begin to form earlier, at the early stage. Then these vapors will pass through the side tube and they will enter inside the water condenser. Now, vapors of chloroform or liquid with low boiling point, when they pass through water condenser, because the outer atmosphere of the water condenser is cool due to continuous circulation of water, therefore these vapors will begin to condense back into liquid. The same liquid will now fall and get collected into receiver. How long will this happen? Until the temperature in the thermometer is 61. The temperature keeps on increasing, but from 60 to 70 range, all the chloroform will have gone. What happens to aniline? It remains in the round bottomed flask only. Only chloroform vapors will come outside and they are collected in the receiver. So in one side you have chloroform and in the other side you have got aniline. In this way, two liquids can be separated easily. You may ask, sir, what if only one liquid is there and impurities are there? Then you heat the round bottom flask depending on the boiling point of that liquid, then only liquid will vaporize. The vapors will get condensed in the water condenser and the pure liquid is collected in the receiver. What happens to the impurities? Since they are non-volatile, they will remain in the round bottom flask itself. Understood? Again a simple technique. How simple distillation is done? Simple distillation's principle is that it depends on the difference in the boiling points of the liquids being separated or purified. Or else, if you have got only one liquid, then the impurities should be non-volatile, whereas the organic liquid should be volatile. And this technique, simple distillation technique, is used only for those liquids whose difference in the boiling point is large. If the difference in the boiling point of the two liquids being separated is very less, then such liquid mixtures cannot be separated by simple distillation. This is principle. One example, you take the example of chloroform and aniline. If these two liquids are there, then because their boiling point difference is very large, so they can be separated by simple distillation. How is procedure done? You see the experimental setup in the figure. The round bottomed flask has got a side tube which is connected to water condenser, the open end of which opens into a receiver. The mixture of impure organic liquids is taken in a round bottomed flask and the mixture is heated. Upon heating, which is done depending on the boiling point of the liquid, then one of the liquid whose boiling point is low, it will vaporize. The vapors pass through the narrow side tube and then into the water condenser. When the liquid vapors enter inside the water condenser, due to continuous flow of cold water around the water condenser, then the liquid vapors will condense back into liquid and the same is collected into the receiver. What happens to the other liquid with higher boiling point? It remains in the round bottomed flask. In this way, a mixture of two liquids can be separated. What if you have only one liquid? If only one liquid is now having impurities in it, then make sure that the impurities are non-volatile and subject it to simple distillation so that liquid vaporizes, condenses back into liquid and is collected in the receiver. The solid impurities, non-volatile impurities will remain behind in the round bottomed flask. Along with this, there is one precaution that you need to take. Many a times when the liquid is being heated, it begins to bump because there is no air space inside. It is as good as a pressure cooker. So many liquids start bumping. They begin to jump inside the round bottomed flask. So to avoid bumping, you can add into this, you can add few glass pieces or marble pieces, or you can add broken porcelain pieces. What do you mean by broken porcelain pieces? If you have got a teacup or a saucer broken, small pieces of it can be added into it. Then you have got marbles which are nothing but again glass pieces, you can add them, or any broken glass pieces are there, you can add them. It avoids bumping of the solution during distillation. So with these precautions, you can carry out simple distillation. Now, if this method is clear, then we have other distillation techniques like fractional distillation, distillation under reduced pressure and steam distillation. We shall see about and we shall explain about these methods in our next class. Thank you.